short lesson. All right, starting over. So today we're doing the second day of improper integrals. This is the last section of the unit. Yesterday we did integrals where the one or both of the limits, the bounds of the integral approached infinity. Today we're doing integrals where the integrand, or the function you're integrating, has a vertical asymptote somewhere in the interval. All right, so we have three cases of what might happen. You can either have a vertical asymptote at the lower limit, a vertical asymptote at the upper limit, or a vertical asymptote in between the two limits. When you have a vertical asymptote at the lower limit, you want to take the limit as, we're just going to use A for all of this, as A approaches that lower limit from the right. Lower limit, you always approach from the right. Upper limits, you always approach from the left. And if you kind of think of them, instead of lower and upper, we're going to be doing this today. Instead of thinking of them as lower and upper, if you think of them as left and right, because they go low to high, so they go left to right on the x-axis, then we would want to approach this guy from the right. So if you ever have a vertical asymptote at your lower limit, you're going to do a limit from the right. If you have a vertical asymptote at your upper limit, you're going to do a limit from the left. You approach it from the left. If you have a vertical asymptote in the middle, you have to break up the integral into two integrals. So one where you approach the asymptote from the left, and one where you approach the asymptote from the right. The limits might not seem important, but there will be problems where they actually become very significant, where if you didn't have the limit there, it wouldn't make a lot of sense on how to evaluate the integral. Let's do. You're still copying. While you're copying, I'm going to. Even that's not working. That's not good. I'm not having good technology response today. I wonder if I have to turn it to this. Whoa. That's not good. It's not going to do it. All right, that's okay. Oh. Okay, all right, so remember, you only have to worry about recognizing these when you have a definite integral. If you have an indefinite integral and there's a vertical asymptote in the middle, it doesn't matter. You still just do the integral the same way you've always done it. You never really even thought about it when you had the integral of 1 over x, or 1 over x cubed. Let's do that one, right? You never thought, oh my goodness, what happens if x is 0? Can I still evaluate the integral the same way, right? You just do it, right? So it's the same thing always. For indefinite integrals, this is moot. For definite integrals, that's where this comes into play. So we're only talking definite integrals. For a definite integral to be improper, if it's improper because one of the limits is infinity, that's easy to spot, right? You look at it, you see an infinity, oh, it's an improper integral. What you now have to start thinking is if you have a definite integral with regular numeric limits, take a second and check the integrand, and just to make sure there's no vertical asymptote inside. Because if there are, you've got to approach it a little bit differently. All right. So, first one, where is the vertical asymptote for this problem? At x equals 0, right? So it's at the lower limit. So we are going to rewrite this as the limit as a approaches 0. Since it's the lower limit, or the left-hand limit, are we going to approach it from the left or from the right? From the right. So we're a little plus there. All right. So we have the limit of the integral from a to 1. That's a 1. It doesn't look anything like a 1. it's just one of those keys. Okay. Let's see if this is gonna line up at all. Okay. Because it's not responding. Yeah, we tried. So, all right, so I'm gonna think of this as x to the -1/3 dx. All right, take a second, do the integral, plug in the limits, see what happens. No, you didn't mark one, right? It's all right. All right, so let's see. Antiderivative x to the -1/3, so you get 3/2 x to the 2/3 from a to 1. So we end up with 3/2 times 1 minus 3/2 a to the 2/3. So if you plug in a 0 for a, what do you get? Yeah, you get a 0, right? You don't get an undefined. You just gotta make sure you're not getting an undefined, because if you get an undefined, then it's probably gonna be infinity or negative infinity, right? But in this case, you plug in a 0, you get 0, so your answer is just 3/2. Is that okay?
Yeah.
Yeah,
Well, if you're just trying to find that, like, why would you need it? Wouldn't you just like do it like a regular?
You
Yeah,
could.
That's what I was.
you could, but technically you would be, numerically your answer would be correct. But technically your math would be incorrect. So you would be doing kind of incorrect math, but getting the right answer. It'll come into play more when it approaches infinity, right?
Alright,
Yes.
How do you know that the limit is approaching 0 from the right?
Oh, okay, so we know to worry about the 0 because that's where our vertical asymptote is, right? So if we think of the integral going from 0 to 1, 0 to 1, we would always approach the 0 from the right, because that's the side we're coming from when we're integrating. Like if we think of the way that this function looks, we've got some sort of an asymptote, I don't know, it's gotta be like something, whatever. It's got some sort of an asymptote there, right? Okay, it's got an asymptote of 0, but, so anyway, whatever. So if we were approached from the left, it wouldn't make any sense. But to get the integral from 0 to right, we're talking about that area under the curve from 0 to 1. And so you have to approach from the right to get whatever that value is. And it's weird because sometimes, it's just like yesterday, sometimes that area is going to be finite and sometimes it's going to be infinite. So you have to just do the integral to figure out which way it's going to go. All right, so give this one a try. Very similar but different.
What makes you divide by 0? What does x have to be? 27. So you're gonna do the limit as a approaches 27 from the left.
Hey guys, where is the vertical asymptote for this function? At what value of x? 27, because that's what makes you divide by 0. So we need to do a limit as x, or as a, approaches 27. That's our upper bound. We're going to do it from the left or the right? From the left. So we're doing a limit as a approaches 27 from the left. Did you get the right antiderivative? Be very careful with your negatives. There's a lot of negatives and double negatives and triple negatives in these problems. Those negatives will get you. Do I get 27 house? If you got negative 27 house, check your negatives. Good, let's try one. Ooh, sure, of course. You sure? Okay. Alright, let's try one that's a little bit different. It feels like it should be easy. And it is, relatively. It's an easy integral. Where's the asymptote? At 0. So asymptote's just at the lower limit. This one is, the only thing that's different is the type of answer for this. No, it's not a natural log. Regular old power law.
I mean, you would never write it that way. Just like this 0 there.
Oh, uh-oh. But it's a limit, isn't it? It's one of the reasons that we are thankful to have limits. Okay. I heard none confused. Do you guys get how to set up the first step? Yes. Okay. Okay, good. That's where we'll go. All right. So you guys got the first step, and then hopefully you all got the correct antiderivative. Right? Good. And then you plug in your numbers. So you've got -1/2 minus -1/2a squared. All right, so -1/2, that's just -1/2. So we have plus 1/2a squared. If we plug in a 0, we get 1/0. All right, can you L'Hopital a limit that has a value of 1/0? No, L'Hopital doesn't apply to 1/0, it applies to 0/0, or infinity over infinity. 1/0 is not a L'Hopital. So let's go back to September, right? Ignore the 1/2 for a second, let's just look at this part. We have the limit as a approaches 0 from the right of 1/2a squared. Way back in September on your limit test, if you plugged in a 0 and got 1/0, so a not 0/0, that means that you have a vertical asymptote there, right? Whenever you have a vertical asymptote and you want to know, so whenever you have a vertical asymptote from the right or left, the function's either going to approach infinity or negative infinity, right? Oh, good. Okay. So to determine if it's going to approach positive or, so you know the answer is going to be positive or negative infinity, you just have to know which one. So to know which one, the way that I do it is I pick a number close to 0 from the right, like 0.1. Plug it in and you just check the signs. So if you get a positive over a positive, it's going to positive infinity. This is going to positive infinity. So now, so now you end up with negative 1/2 plus infinity, which is infinity. So this integral, is it converge or diverge? Divergent. Divergent. That's okay. We'll talk about it next year. Because that's really not the focus of this unit. It's just, I'm just showing you the words because you have to know the philosophy. But next unit is all about convergence. All right. So, last one. Is this the last one? Yep. Okay. Last one. Where is the vertical asymptote? At what value of x? 1. Uh-oh. So, it's not a lower limit, it's not the upper limit, it's in the middle. We're going to have to break it up, right? And breaking up is not hard to do. Oh, so. All right. So anyway, what we do is you do the limit as a approaches. You can, and it doesn't matter the order. If you want to do this one first and then that one, it's fine. You're just adding them together. So you replace your upper bound with an a limit as a approaches that vertical asymptote from the left, and you replace your lower bound with an a and take the limit as a approaches that vertical asymptote from the right. Your neighbor, see if you guys got similar
Methods and answers.
for the antiderivative or for the.
Well, yeah, I guess they don't have, like, even if you plug in the one that you.
Oh, for this one, yeah, because if it was an infinity-ish kind of thing, then it would matter, but yeah, for this one,
Oh,
it says
You
when you plug in,
it
it
works
just
out
gets
to the same
zero.
thing anyway, I'm pretty sure.
When you have, when your A value, your limit value is approaching zero through the asymptote. No, because you're, when you take the antiderivative, there's no more real asymptote. Okay, did you get the correct antiderivative? 3x minus 1 to 1/3? Any questions on the antiderivative? Okay, so you plug in an A, plug in a 0, plug in a 3, plug in an A, right? So just plugging everything in, you end up with that. What's nice now is if you plug in the 1, do you get a vertical asymptote or do you just get 0? You just get 0, right? So this is gone, and your final answer is just 3 plus 3 times the cube root of 2. Yeah? Is that a drop the mic kind of an arms folded or an indignant kind of an arms folded?
It's like I'm tired kind of.
All right, good. So 3 plus 3 root of 2. Any questions on this one? Good. So the main point of today, what is an improper integral? You guys tell me, what's an improper integral? An integral that is not proper. Yes. Has limits that are approaching infinity or has a vertical asymptote inside the integrand, right? Okay. All right, what are the wonderful things that I used to rewrite all improper integrals with? Limits, yay, limits. Okay.